The broadcast is now starting. All attendees are in listen-only mode.
Good morning. It looks like everybody's here, so let's get started on time. My name's Tom. I work with Hydro International, and I want to thank you for attending this morning's webinar. This morning we want to focus on Minnesota and some of the unique challenges that it has as it relates to clean water and proven product requirements. We will illustrate a few of Hydro's products that are designed to meet the stringent regulations. And in Minnesota, there's a couple things that are very important to all groups on the team is phosphorus and also TSS removal rates. So I'm here with my colleague Ben Lydon. I'd like to turn it over to him for a few minutes.
Hi everyone, thank you for coming. As Tom mentioned, my name is Ben Lydon. I've been with Hydro for 5 years now. I started in the engineering department and now I've made my way to a technical sales supportive role. So that's why Tom and I are here together. Tom has been with Hydro International for 10 years. He manages Minnesota and Wisconsin in his territories. And together we have over 15 years experience, so we're a good group to be talking to when it comes to meeting your treatment objectives. I just want to lay out the roadmap for today so you can follow along and know where we're headed. We're going to start with a brief industry overview and then tell you about Hydro International, who we are, what we do, and what makes us different. Then we're going to go into the regulatory landscape. There's a lot of data out there when it comes to filters, separators, and removal rates. There are two industry leaders, New Jersey and Washington DOE. The main difference between the two is New Jersey is lab testing, where Washington is field testing. But that's not all you're going to see. There's also, I'm going to show you some industrial case studies where we actually have real world data, and we'll demonstrate how we're able to help our clients. But really, we're going to help you sift through and interpret all the different charts, numbers that you may be sent. Then we're going to go into product details on our separators and our filters and how they're maintained before we talk about moving forward. So the stormwater industry. We all know what we're doing is we are treating the water that comes off our impervious surfaces. What we typically design for is called first flush. So what that is, depending where you are in the country, either the first ½ inch, inch, or 2 inches of rainfall. And the reason we design to treat the first flush is because that is when the pollution is highly concentrated. You know, the first inch, the first 2 inches is what washes off the grease, the soaps, the leaves, and everything off our roadways and into our storm systems. And how we're able to treat that water before it goes into our larger water bodies is through, through BMPs. But what we're going to talk today is about manufactured treatment devices that are put in the ground. What we are looking to remove from our stormwater is primarily sediment, but we'll also talk about trash, oils, nutrients, phosphorus, and how they pollute our waterways. So we're going to open things up right now for a quick poll. We have asked, when it comes to approving one of these devices, is it who decides whether a device is approved or not? You know, we know New Jersey and Washington and different agencies test them and they verify them for a certain flow rate, but who in Minnesota is responsible for saying yes, this device is approved or not? So I'll open the polls now. Okay, it looks like with the feedback, you guys were split 50-50 between city and water district. So, Tom, do you want to talk about who is responsible in Minnesota for approving these devices?
In Minnesota, again, there's so much at risk with all the water and lakes and ponds that area. It really starts with the engineer choosing a device that he feels is going to meet the water quality demands of a specific project. Now, once he's done that, it works its way down the line. It certainly has to have a water district's comfort level, and typically the water district will let the city know, we're confident that this is going to meet the project objectives.
And this is great because it leads right into our next slide. So working together, water treatment objectives aren't achieved by one person. It takes a team, it takes a network, and we've laid that out here. So the regulators, they write guidelines, they write stormwater manuals to dictate to the engineers how water treatment objectives are to be obtained. When you can use a natural system, when to use a manufactured system, when different levels of treatment are required. It's up to the engineer to keep himself educated, stay knowledgeable, and really sift through those manuals to figure out what is needed to meet his site's needs. The engineer will work with the manufacturer, in this case Hydro International, to size a unit, specify a unit, and really it's up to the manufacturer to make sure that they are providing a solution that will work and meet the regulators' requirements. The contractor is, once the project is started, they're making sure what was designed on paper is put in the ground, and that not only the right unit is bought, but it's installed correctly. The pipes are all grouted for watertight connections to ensure its performance. And then once the site is turned over to the owner or end user, their primary objective is to make sure what goes in the ground, what was designed, is properly maintained year over year to make sure that it's performing as intended. But so Hydro International, what's the role of the manufacturer? So here at Hydro, we focus 100% on water quality treatment. We do not sell pipe. We do not sell storage. There's a whole list of things associated with stormwater, but at Hydro, we are just focused on water quality. What differentiates us from our competition is a few things, but one is our laboratory. So we actually just invested $2 million into our laboratory to expand our capabilities. We can now test four times as much at one time. So our PD, our product development team, is constantly testing, retesting, redeveloping our products. And what our product development team does is they actually build, design, enhance our products. We don't purchase other people's technology. We develop our own technology in-house. Another differentiator for us is our maintenance and our industrial divisions. Not many other stormwater companies will get into maintenance or will get into the industrial sector. We are industry leaders in both. And you may not know or think right away that industrial projects and maintenance go hand in hand, but they do. Because really, on an industrial site, you don't have to meet regulations. You don't have to be approved by anyone. You have to meet your benchmarks, and how you do it is up to you. They don't tell you whether you need a filter, whether you need a separator, whether you need better housekeeping. They say, here's your benchmark. This is what discharge limits you have, and it's up to you to get there. So Hydro works with the client not only to specify a device that will work to meet those requirements, but then we install maintenance contracts to make sure that that filter is working as intended year after year, so that they are not in any violations or subject to any fees. And what both of these, both our maintenance side and our industrial side, has now provided us is visibility into the entire life cycle of our products in a way that we never had before. So once these are installed, we're able to inspect them, test them, maintain them, and improve them if need be. So we have full insight in the performance that we're getting. Our capabilities don't start there. We actually initially we're a wastewater company, and so some of our separators look very similar to our wastewater products. The Downstream Defender is a smaller version of our Grit King device. Aside from wastewater, we're involved in flood protection. We also sell a valve that deals in water quantity versus quality, so regulating the amount of flow that is allowed to move downstream or through a piping system. We're involved in combined sewer overflows, but the newest technology that we're creating, developing, and bringing to market is our telemetry work. Using smart data. So nowadays, if it's not on your cell phone, people don't want to use it. We are putting data loggers inside our devices that will tell you live 24/7 how much sediment is in our devices in the sump, what the water level is in the sump, how much flow is moving through our system, so that when it comes to maintenance, typically we say inspect annually, maintain every other year. Now your inspection is now opening up on your computer or on your smartphone the software that will tell you whether maintenance is needed or not. Is your sump at 50% capacity or 75% capacity? So that's one thing we're doing. And how we're able to stay ahead of the curve when it comes to new innovative technology is we collaborate with our other divisions. So we're in 33 different countries with over 350 employees. So if something is developed in Australia, in New Zealand, in the UK, they will share that information with us. So we're not only doing what works well in the US and in Canada, but we're actually staying on top of the industry and across the whole globe. So let's talk about our products. Our products are shown at the bottom, moving from left to right. On the left, it is our hydro dry screen, which is a baffle box. This is large flows and large particles, soda cans, McDonald's wrappers, palm leaves, bulky waste. As we move to the right, our flow rate decreases, and so does the size of the particles which we're able to collect. So our filters, this is anything that doesn't settle, typically in the PSD range of below 50 micron. And that's your metals, your nutrients. So our hydro dry screen, the baffle box, that can treat up to 80 CFS and can handle up to 60-inch pipe. Our separators, the First Defense and the Downstream Defender, typically work in the pipe range from 6 to 36-inch pipe and can treat flows up to 25 CFS and handle flows up to 38 CFS. And they really specialize in 110 micron down to 50 micron. So you can compare that to, say, beach sand is 110 micron and 50 micron is like flour. Our filters, we have our Up-Flo filter and our bio-infiltrator. As I said, this is anything below 50 micron. Can still handle a wide flow of pipes because we can have them be internally bypassed systems. But really the flows they work well at is 0 to 2 CFS. But which one are you going to choose? Well, that really is dictated by your regulations. So in Washington State, a large filter market. I work in Texas where everything's separators. And in New Jersey, New Jersey has approved all separators at 50% TSS removal and filters at 80% TSS removal. So understanding your regulations is really what's going to dictate which unit you use. But in Minnesota and other parts of the country, we see what we refer to as a treatment train. That is a pre-treatment device using a separator like our First Defense or our Downstream Defender, then a storage system, followed by a polishing filter downstream of that storage system. So how it works is water comes in at high flows. So we use a separator that can stay online up to 38 CFS, and that is removing a lot of the TSS, the grit, the oil, so that it does not clog your storage systems. Then at the outlet of a storage system, you usually have some sort of a control structure that regulates the flow. which it comes out, lower flows, and we use our filters that really have that polishing effect. Now, the stormwater industry is very segmented. It changes at a state, county, city level. Sometimes what you do on one side of the street, you can't do on the other side of the street. And we have many examples that we could show you. But there are some commonalities between all areas. Separators are generally used for pretreatment. Filters are always used when an enhanced level of treatment is needed. But you'll see things like 50% TSS, 80% TSS, 40% phosphorus removal, 50% phosphorus removal. But what you need to understand, whether you're talking about New Jersey, whether you're talking about Washington or Virginia DEQ, those are minimums, and a lot of the regulations cap your device. A good example of this is NJCAT. So per New Jersey testing, it's all lab-based testing done in New Jersey, and it is a common way to verify the performance of all the different manufacturers and models out there. So what they will do is they will say, your 4-foot model is approved to this flow, your 6-foot to this flow, and so on and so on. With our New Jersey, they cap, like I said, all separators at 50% and filters at 80% TSS removal. However, when we were being verified and going through the testing protocol, our Up-Flo filter actually showed that it could obtain 98% of TSS. So although it's capped at 80, its actual performance was verified at 98% removal. So this is the data that's out there. It can be misinterpreted very easily, and we're here to help clear things up. But when I talk about real-world data, I've highlighted here a case study. This is an industrial application, a site in California. It's a metal recycling facility where they actually were at risk of heavy fines, large fines, because they're in violation of their discharge. You can see here on the right, we've shown TSS, iron, copper, some different metals at which they're exceeding their benchmarks. Their benchmarks are shown as the horizontal line. And in this case, what we did is we actually shipped them a 5-gallon bucket empty, and they sampled their stormwater, and we'll do this for anybody. They sampled their stormwater, and they were able to send it back to our lab, and we actually passed their stormwater through a mock column test, and we can tell them with confidence whether we think our product is right for them or not. In this case, it was. So our Up-Flo filter actually brought them from about 200 milligrams per liter of TSS down to essentially 0. So luckily for them on California, in this job, our Up-Flo filter was able to bring them below their benchmarks in every area they were exceeding.
Another good example of testing agencies having a minimum standard and understanding the concept that although the minimum standard for acceptance is applied to all units, the actual real-life removal efficiencies vary a lot from manufacturer to manufacturer. In this study in at University of Alabama, for example, the laboratory testing of using the CPZ media has a demonstrated removal of 85% of 106 at a filtration rate of 25 gallons per module. The Up-Flo filter removes 72% of total phosphorus, with a control particle being material for the University of Alabama filter study. Now, that particular statement there is really important to the folks in Minnesota. It's a very focused issue. In the Midwest, in Minnesota where you're located, the NURP and the PSD is coarser than the 106 that was used in the Alabama study. So the filter base on a 25 gallon per minute flow removes at least 80% TSS. Again, just showing the difference between the minimums acceptance with testing agencies, and the real life performance.
Okay, so let's talk about our products and how we meet the regulatory requirements out there. Working our way through the treatment train, our first stop is the pre-treatment devices. So in our case, it's a downstream defender or a first defense. Both are hydrodynamic separators. Both utilize vortex technology to have high removal rates of sediment. But there is one main difference between the two units. You'll see here on the first defense, on the right, it has an internal weir wall. So this is an internally bypassed unit, and what happens is at treatment flows, water is passed through our internals for treatment before making its way to the outlet pipe. At high flows, water is able to go up over the weir wall and downstream. So this device was commercialized in, I believe, 2012, where our downstream defender was about 20 years before that. So the reason for the first defense is we talked to engineers. They really liked our performance. They liked our technology, but the downstream defender was slightly limited, and I'll explain why. But the first defense was our answer. It's flexible. It can take multiple inlet pipes. It can range in a different of sizes of which size pipes it can handle. But the downstream defender is a full flow treatment device, meaning there is no internal bypass, so all water that moves through the downstream defender will be treated. Because of this, it has a slightly smaller range of flows at which it can handle, so the treatment flow and the peak flow have to be relatively similar compared to the FDHC. The other part about the downstream defender is it has a submerged inlet that is on tangent. So when it came to multiple pipes, it was a little bit hard to configure, which is why we have our answer of the first defense high capacity. But when it comes to, you may be asking yourself, why would I specify a downstream defender over a first defense? Because the outlet pipe has that hard connection to the internals, it is the premier device on the market when it comes to washout. And what I mean by washout is resuspension of sediment, oils, floatables at higher storm events, where when you're using the first defense or any other internally bypassed system that's available, when you have your 50-year storm, it's going to go over the weir walls and it has the potential to take any floatables with it. The downstream defender at the 50-year storm, it has no risk of floatables making it downstream. The downstream defender is also the only approved separator on the market that does not have an internal bypass. Now, the key to performance for any separator that's available out there is how much time it can hold that water inside the system before it leaves through the outlet pipe. All these separators work through gravity, so the more time water molecule spends inside our system, the more time that sediment has to fall to the sump. So our goal is to have smooth flow paths, little turbulence in our system, and to make the length of those flow paths as long as possible. So for the downstream defender, the water comes in on tangent, which induces that vortex in our system. You'll see here two distinct flow paths, one shown in magenta and one shown in blue. The first flow comes in and works its way around our internals. The blue path is when the vortex comes up through our internals to make its way to the outlet pipe. So again, more time in our system means more time to settle. The profile view shown on the bottom right shows the submerged tangential inlet of our downstream defender. Now, so we grow, we enhance our products. So like I said, we took what worked well with the downstream defender, the vortex, the two distinct flow paths, but we also listened to the engineering community and said we want multiple pipes, different elevations, and so our answer was the first defense. With the first offense, we actually use our internals. So as water comes in, our internals are what induce that vortex motion. And in order to keep the water in our system for longer, what we do is we actually have an outlet chute shown here, but it's facing the other way. So as water comes into our systems and starts to swirl, it actually has to stop, change direction to move outside of our system. Now, what's unique to the FDHC, the first offense high capacity, is it works very well with an inlet grate, as shown, but it can also be a standalone inlet grate. So if we look at our picture on the right, if we didn't have this second inlet pipe, you could actually replace the catch basin with an FDHC, only having an outlet pipe, and it's a way to reduce the amount of structures on your site.
Thank you, Ben. I think that's a really important part of any treatment train. The separators up front take a lot less strain off storage than the ultimate filter. Let's just take a minute. Very simple, but very, very effective parts and pieces that go into this Up-Flo system. At the top, you can see an inlet grate. These vaults have an option of using a grate, curb inlet, or if not needed, can be buried underground with 3 access covers, depending on the size of the vault, on the top to get into the units for maintenance. The actual vault itself, we have a little bit of an advantage where the 25 gallon a minute flow per module is high. We can typically keep the footprint and the vault size to a minimum. As you see in blue, these are the actual filter modules that are bolted onto a platform on the bottom. There's a 4mm screen that's also connected to the bottom section there. And this is just the water comes in, it gets forced up through the filter. That'll tend to trap any floatables or large items that, we don't want them getting involved in the filter. It keeps them away from them. In yellow here is a bypass hood. If you happen to get your peak flow, it just travels over the top of the filters, and the bypass hood controls with the outlet structure. Now, you'll see, we have an outlet module and a drain down filter. Now, the drain down filter, the purpose for that is once the storm's over, things have settled down a little bit, we want a way for the water to drain down into the sump area and stay away from the filter media so that it isn't sitting in water all the time. This helps to extend the life of the media bags. Now, I want to show just a quick video of the path of the water and a couple of important items on this. Okay, here's our 4-foot manhole. Our filters can come in either a 4-foot manhole or a vault. The vault size, again, depends on water quality flows. But we can put up to 6 modules in a 48-inch structure. Talk about a small footprint. That's a small footprint. The screens are the same. The modules are the same. The outlet module and bypass hood are all the same in this 48-inch manhole. A nice look at inside of those modules again. You can see on the top for maintenance, these little handles just slide to the right, the cover comes off, and the modules come out. Now, I want to stop this just for a second because I think it's important to the function of the 48-inch manhole. You notice the inlet chute has a variety of different angles that it can enter this unit. So that if you have a project and the inlet pipe, is on a tight angle to the outlet pipe, most of the time this 48-inch unit is going to solve that problem. Now, when we get to the vaults, in a second here, it's going to show you the travel of the water flow, which is very important. Again, you see the screens down at the bottom. Keep the floatables and large objects away from the actual filter. Water comes in from the left. I want to pause here just for a second. You notice the inlet and the outlet pipes have very little change in elevation. This is unique to the Up-Flo system. We don't need a large drop to make this work. Our project engineers, most of the time, if a no-drop situation is required, we can configure the modules to accommodate that. So when you're looking at a project that you really don't have the drop needed for a lot of other systems, the Up-Flo filters are a good one to take a second look at. As you can see, the water getting pushed up through the filters. Fines are settling down into the sump. This is the inside of the media bags, small particles. The sump area is where most of the fines are all going to remain. The water travels up through a pathway on top of the filter modules and works its way out to the outlet pipe. Now, at times of when the unit goes into bypass, you can see that when it goes into bypass, you're going to be able to see the outlet module in the bypass hood taking care of any increased flows. Quick look at maintenance. Vac truck is the only thing you need. A couple of people or even one person to change the media bags. You'll see the vac truck come up, the grate or the lid's pulled off in this slide here. They spray some water on the filters. They pump out the sump area. They get rid of those fines. The covers come off, the lids take the media, lift them up to the surface, install the new meters, and you're all done. Truck drives away, and that's it. So you do have multi-stage, multi-components, and very simple, again, but effective solution. I want to take a minute. This is kind of interesting. It has to do a little bit too with, what Ben was talking about, with regulations and that type of an issue. But this is an install map of Minnesota. Matter of fact, the first Downstream Defender was shipped into Minnesota about 15 years ago. So it's not like, it's the first time we've been here. But when you look at the map, I included your neighbors to the east, Wisconsin. And the reason for that, you see a lot more dots on that Wisconsin map than you do in Minnesota. And the basic reason for that is the whole state of Minnesota goes under a program called WinSlam. And WinSlam is the program that's evaluated all your data. We submitted it to them over a period of years. And, we're approved on the WinSlam modeling. There's only 2 filters in the whole state that have that approval. Hydro International with our Up-Flo CPC media is one of them. And one of our major competitors is the other one. Definitely a high level of confidence in our filter in Minnesota and Wisconsin. Now, to me, this is one of the most important portions of the whole system. We've talked about pretreatment, we've talked about storage and then filter at the end. But Hydro International is the leader in maintenance, no question about it. We understand how important this is to protect the waterways, lakes, and ponds. Pasquale is our manager that handles our maintenance all over the United States and portions of Canada. He's a very sought after guy. In 2017, he presented technical papers to StormCon in Seattle, WETEC technical session in Chicago, and the New England Real Estate Journal in Nashville, New Hampshire. In 2018, he was invited back again to StormCon to do a presentation in Denver. And in 2019, he's already been to the Environmental Water Research Institute in Minneapolis and invited back again to StormCon in Atlanta. And let me just take a second, again, how committed and how I feel about how important maintenance is. If you take a look at how a product is developed, sometimes it can take years in product development. We test it, we look at it, we're trying to meet a solution that needs to be presented to the water quality industry. After the product development phase is over, it can take years and considerable amount of dollars of investment to apply to various testing agencies around the country. Now, after that is done, and we spent the money and time and effort, shared our knowledge of the treatment results of our devices, engineers take that information and they decide what unit to put on a set of plans. Goes out to bid, the units eventually purchased, and it goes in the ground. Now, what happens, and unfortunately it happens most of the time, that of all these efforts, they kind of go down the drain, to speak, if they're not maintained regardless of the manufacturer. All units after time would just stop working. This is a quick video of how we're doing some maintenance on a 48-inch 6-module filter unit that was installed at the Dane County Airport project. The vac truck shows up, uses his hose, cleans the top of the units on. They're pumping out the sediment in the bottom. Sump area gets good and clean. As you can see the concrete now. Now, once the vac truck's done this cleaning, they pumped out the sediment. One person can go down in there and just change the filters. In this case, there were over 2,000 pounds of sediment removed from that device. Again, no, he's grabbing the bags with his hands. No extra lifting devices needed to get those filters out of there. These are the spent media that can just be disposed of. And it shows the new filter on the left. Once that's installed, the unit again operates like it's brand new. Just an example, again, here's your 48-inch manhole, nice and clean. After 18 months of use, the sediment begins to build on top of the module covers. The bypass hood looks, again, sediment on it. The one on the right is after 36 months with no maintenance. You can obviously see the sediment in the sump has already worked its way up about halfway to the filter modules. So that unit at this stage of the game is pretty much inoperable. Now we want to talk about that team again just for a second that Ben mentioned before. We all have goals. Some of them are a little bit different, but we have to satisfy with our product all of the team members. The engineer, site requirements, the manufacturer, we need to provide adequate solutions. The contractor has to know how to properly install. The owners inspect and maintain. And the regulators, of course, are controlling this a little bit about wanting a comfort level that the needs are going to be met for whatever project it is. Life cycle costs, again, high interest of the owners. And actually, the initial costs are very important. And the initial and life cycle costs vary a lot between different manufacturers. The regulators certainly want their treatment goals met. The engineers looking for product performance and data to back that up. The contractors and the engineer look at footprint and size. Keeping that as small as we can is a benefit to all.
And I will say, Tom, that when it comes to our Up-Flo filter, as far as maintenance costs are concerned, the fact that we can just throw our media bags out in the garbage and there's no hazardous requirement, it's definitely one of the cheapest filters out there to maintain. And as far as the regulatory approval, it has more approvals than any other filter on the market.
It does. Well, again, we want to thank you for your time. Certainly, if you see fit, send us, email us one of your projects with a plan sheet. We'd certainly love to work with you in the water district authorities to create a comfort level on our product and what it can actually do. We'll help you size, specify, and maintain your next quality water quality device. Now, an important piece of this that I do want to mention, we've talked a lot about pre-treatment, storage, filter on the downstream side. We do work with a few very high quality, excellent companies that do provide storage. So that if you do send that plan along, or you're looking at an alternate maybe, everything's come in over budget for you, we can involve our channel partners. They're well qualified to recommend a storage system and quote it for you so you have a complete package.
So one other thing that Hydro International does very well is continuing education. We have, this webinar was targeted specific to Minnesota, but monthly we put out a webinar that goes nationwide to the U.S. and Canada. You can see we have one tomorrow that's on industrial processes that may not really pertain to you, but Thursday, November 21st, we're doing a stormwater filtration system. So really taking a technical look at the filters that are available on the market, how they work, typical applications, and maybe some pros and cons with some of them. But if you're interested, it's a great way to earn a PDH credit by just sitting at your desk. And after this webinar ends, you'll be sent a quick survey. Please fill out the survey and you could win a $50 Amazon gift card. And there'll be a couple places where you can ask questions. But again, feel free. Both our emails are listed below. Send us any questions, comments, or concerns you may have, and we'll be happy to work with you. Thank you.
Thanks again. You know your time's valuable.